All right, so next we have Thomas on stage. Thomas is the founder and president of Network Redux. He's going to be speaking about journey from a traditional on-prem data center to AWS. What are the challenges and the opportunities that they have faced? Can we have a round of applause for Thomas, who's coming all the way from Portland, Oregon?
Well, my name is Thomas Brennicke, and I do come from Portland, Oregon. I'm the founder and president of Network Redux. We're based in Portland, Oregon, but we also have an office here in Kochi. I started Network Redux actually before AWS existed in 2004 while I was studying at the University of Portland. We started as a traditional managed hosting provider, dedicated server, shared hosting. And then in 2011, I met Sujith Mohan, who's our executive director of global services, and we formed Network Redux India to help provide global coverage to our 500 clients throughout the world. And today, I'd love to talk with you about the journey one of our clients took from our on-premise data center in Seattle, Washington to Amazon Web Services. Before we begin, I want to talk about 3 of the common methods we see our clients utilizing when migrating out of our on-premise facilities to Amazon Web Services. And the easiest is referred to as rehosting, also known as lift and shift. And this is effectively taking server resources and migrating them over to Amazon, most likely on EC2 instances, including databases as well on EC2 instances. Replatforming, I would say, is the most common we see, and this is the one we're going to talk about today. This is also referred to as lift, tinker, and shift. In this case, we can take existing servers and services and migrate them to Amazon, but also map them to AWS-specific services like Elastic Load Balancers for load balancing, CloudFront for content delivery, Aurora RDS for database services that are fully managed and take the burden off of our team in managing the infrastructure. And lastly, there's refactor, which is to essentially rebuild the application from the ground up to be cloud native. And this is a complex initiative that requires a lot of developer buy-in, a lot of stakeholder buy-in from many parts of the organization, and can be complicated. So in our case, our client chose replatforming. So how did we do it? Well, we have Dajish, and he did facilitate this migration. This took about a year working with our partner in Croatia, who's the #1 direct reservation platform as a booking engine for hotel reservations in Europe. And Dajish and I traveled to the client site and began the discussions, and it took a year for us to actually get to the end point, which was the migration. So some of the challenges we faced, again, this is the #1 direct reservation platform in Europe, servicing millions of requests per day from booking engines such as Google, Expedia, and Booking.com. As well, because they're processing credit card data and credit card transactions, it has to be PCI DSS Tier 1 compliant, which it was in our facilities in Seattle. So the client and Network Redux chose replatforming. This is a way to get them into the public cloud, take advantage of some of the AWS-specific services like Aurora, and then in the future consider containerizing the application and leveraging Kubernetes. During the planning phase, we implemented a proof of concept environment for the client to begin testing how their application would work on AWS. And this client was using a traditional deployment methodology using SVN and Subversion, if anyone is familiar with Subversion. So we needed to move them to a Git-based deployment strategy. And we also needed to isolate their environments into true dev, staging, and production, because at the moment they had just been using a small dev environment and a large production environment. They also needed all of this to happen with less than 2 minutes of downtime. And at the end, upon executing the migration plan, we needed to ensure that they had a full auto-scaling environment that leveraged CI/CD pipelines using code pipeline and code deploy. And we also needed to ensure, again, that it happened in less than 2 minutes. And in the future, we would consider Kubernetes and container orchestration when the client was ready to consider those. So here's an overview of a traditional on-premise data center setup. I don't know if any of you have ever worked with on-premise, but it's not very pretty. Every layer of the architecture is dedicated. For example, dedicated Juniper SRX firewalls, dedicated load balancing devices, dedicated web servers, application servers. We were using a technology called DRBD which is a block level replication strategy to share storage between multiple web servers. And today AWS has a service called EFS, which makes this much simpler for us. And then we have the traditional master-slave architecture for database services for our client, and a Redux Sentinel cluster for caching purposes. This was an N+1 architecture, although it was in a single data center. And one of the reasons we wanted to move them to AWS was to take advantage of multiple availability zones within a single region. So going into why AWS. Well, networkredux mentality is to do a few things and do them really well. So we chose AWS in 2015 and started migrating our clients to Amazon Web Services. And we've been doing this for the last 4 years. This is one of the larger migrations we've done. This client's clients are in the EU region. So they needed to lower the latency between the application and the end users. And to do that, we chose the Frankfurt region for them. And they also wanted to take advantage of the elasticity of the public cloud. Who doesn't? Because that's one of the reasons the public cloud exists. We're moving them from dedicated hardware, managing this dedicated hardware, to the elasticity of autoscaling groups, read replica autoscaling, features that they didn't have, they wanted to start taking advantage of. And they were using the legacy deployment model. We wanted to move them to a DevOps best practice approach using a true CI/CD pipeline that we built for the client. And they wanted to implement CloudFront as part of this process to ensure that asset delivery of media assets was fast to all of their clients throughout Europe. So when we were planning out the migration, we started mapping which services of on-premise would map well to services on AWS. And we were also planning to implement the CAS and best benchmark standards and PCI DSS best practices while building this client environment. We used a configuration management tool called Ansible for managing the operating system environments of the clients. And down the stack, we chose a variety of Amazon services such as Route 53 for DNS, Elastic Load Balancers for load balancing, EC2 instances and auto-scaling groups. And we did choose Aurora RDS for our client in this configuration. So when we're building an account and security comes first, we like to segment various environments into their individual unique accounts. So for example, the management account, the QA account, the stage account, the production account. And the benefit of this segmentation is primarily security driven. If one of the environments were to be compromised, such as development, that bad actor would have no access to production. These individual AWS accounts are able to talk to the management account using VPC pairing. So the AWS architecture we planned for them consisted of a custom VPC which spanned across multiple availability zones. And again, high availability was paramount in this migration. NAT gateways for egress traffic, Elastic Load Balancers for distributing traffic to the application and web servers. The EC2 instances is where the web servers and application servers reside, and they're configured within an auto-scaling group. And then Elasticache was chosen for caching, and Aurora RDS with read replica auto-scaling. Their environment is heavily read dependent, so the auto-scaling of Aurora was fantastic for their use case. And then this was actually a blessing for us, Elastic File Storage, because managing DRBD, which is an open source project, was moderately painful for our team. There was no commercial support. Any issues and errors were on us to resolve. And Elastic File Storage, which is very similar to network file storage, if any of you are familiar with NFS, took a lot of pain out of our administration tasks. So this is a high-level view. We were using Route 53 actually for this client before we began the migration, which made this a lot easier on our team. And Amazon provides a web application firewall called AWS WAF, which we implemented for this client as well. Okay, so the first step was building the AWS accounts, benchmarking them against CIS best practices, ensuring PCI DSS standards were applied. We do provision our infrastructure using CloudFormation templates. So the VPC infrastructure was provisioned using CloudFormation. And then we enabled the standard tools that our team uses, such as VPC flow logs, CloudTrail alarms, config services. The next step in preparing for the migration was configuring the servers and services. So as we discussed, the ELB for managing traffic between the application and web servers, and all layers of the architecture were built across multiple availability zones to ensure high availability. And then integrating GitLab, code pipeline, and code deploy for our client, and building some documentation to show them how to use these services. This was integral in that it would allow them to automatically deploy and trigger auto-scaling events based on these deployments. And then we tested for months, both teams, every layer, ensuring everything acted as it should in the event of a failure, load testing to ensure auto-scaling worked as expected, and this process did take a couple of months to complete with our client. So then we drafted the plan, and we also drafted a rollback plan. So because DNS had already been transferred to Route 53, we lowered the TTL settings to about 30 seconds to allow for a very quick failover. And the migration plan consisted of a handful of steps. At a high level, we had the client put their application into maintenance mode. We were going to break replication, and promote Aurora as a standalone cluster, switch the DNS records to point to the ELB. And then also, after the migration was completed, we would reverse replication from Aurora to on-premise in the event that we had to transition back quickly. And that was a key part of the strategy. That was Dajish's idea and Sujit Paley's idea, and it worked well. We didn't actually have to roll back, but it was there just in case. Once this was completed, we'd have the client remove maintenance mode. So why didn't we use database migration services? We required absolute control over the migration. We also needed to finish the migration in less than 2 minutes. So we chose to employ a chain slave in between our on-premise database architecture and Aurora. And we would use this chain slave in a reverse fashion when we had completed the migration so that one of the slaves could be turned up on-premise in the event that the migration did not go well. Final migration, Route 53, still directing traffic to the on-premise environment, but we did have database replication coming from our on-premise environment to the chain slave down to Aurora. Then we flipped DNS, broke replication, reversed replication. All of this occurred in less than 2 minutes of downtime for the client. Now, there were a few items that came up along the way, but nothing that caused an outage. We did not have to roll back. We were able to address issues with the ELB once production traffic was shifted over that we saw. But again, less than 2 minutes of downtime for the client. And then we decommissioned on-premise after 30 days. So we gave the client a grace period of about 30 days to ensure everything was operating as they expected it to. And then we called it good. So the roadmap for this client, they are invested in being cloud native. And so in 2020, we'll be working with them to re-architect the application to be cloud native and take advantage of microservice-driven architecture. And a service we do love is EKS on AWS, and so that will be part of the strategy for them in 2020. Thank you. Thanks for having me.